Okay, so this is problem 3.2.63, and they give us this function right here, h of x equals x times x minus 5, x plus 2, and x minus 6. And they ask us to pick the correct graph, okay? And it's going to be hard for me to recreate those graphs, so I may have to keep lifting the paper. But let me just talk about the things that we can glean from this right here before we start looking at graphs. So the first thing is the power function on h of x here is x to the fourth, or we could call it h of x is x to the fourth. Now the reason I'm getting x to the fourth, if we were to multiply this all the way out, we would have x, we'd have to multiply it through here, and then we'd take that through here, and then through here. The highest power that we would see in the problem would be x to the fourth. Okay, so that's what we would call our power function. So it's whatever basic function it's going to resemble. With the x to the fourth, knowing what the power function is, we can determine what the end behavior of the graph is. So we know that a quadratic, a square, has, this type of a graph where the end behavior is always going up towards positive infinity. Okay, and x to the fourth, when you have a positive sign out front, is going to do the same type of thing. So the end behavior on this graph of this h of x graph is going to look like this. We're going to have the graph's going to go up towards positive infinity in this direction, and then same thing here. Okay, so that actually will eliminate a couple of these graphs right off the bat. So if we look at, for instance, D, do you see how D is going towards positive infinity here, but negative infinity there? So this cannot be D. And then the same thing is true of C. We're going up towards positive infinity here and down. And actually, you can eliminate B as well just from the end behavior. Notice the end behavior on B is it's going down and down. Okay, so the answer here is going to be A. And we answered that just simply by looking at the end behavior. But there are other things about this that we could have answered to help us determine what's going on with the graph. One thing is we could take a look at the zeros. And so this is already factored for us. If we were to set each of these factors to 0 and then solve, we could find the x-intercepts of the graph. Okay, so there's going to be an x-intercept at x equals 0. Add 5 here, and we're going to have an x-intercept at 5, 0. Subtract 2 here, and you're going to have an x-intercept at negative 2, 0. And then add 6, and you'll have x-intercepts at 6, 0. Okay, and so you could potentially eliminate some graphs based on that. Also, another property of these graphs that we can use is that we can look at the power on each factor and determine whether the 0 is going to touch or cross at that point. So if it's an even power, then it's going to touch at the 0 and go back up or down wherever it was. It's not going to cross the x-axis. If it's an odd power, then it's going to cross. So all of these have powers of 1. And so all of these are odd, and that means all of these are going to be crossing. So we're crossing at 0, 0, 5, 0, negative 2, 0, and 6, 0. So if we went back to our graphs, for instance, let's see, there was one of them right here in C. You can, I can't see it very well on my, anyways. It's coming down here and it's touching at 0, 0, and then it's going back up. That right there would be another thing that would eliminate C from being one of the graphs, or being a correct graph, because all of these are crossing. This one also, D, is touching right at that point. Okay, so again, that eliminates it. All right. So, we kind of did this via multiple choice because they gave us graphs, but if you were actually trying to graph this, you would then graph these points. You would use the end behavior and the fact that they're crossing, and then in order to determine, how high up or down they're going, you would simply create a chart. So you would take those x-intercept points, and you would divide a chart up, and you would say, let's do a test point. And let's talk about whether it's above or below the x-axis. And we would take that from negative infinity to negative 2. That is our first 0 that we hit. And then we would go from negative 2 to 0. And then we would go from 0 to 5. And then we would go from 5 to 6. And then we would go from 6 to infinity. Okay, so that's essentially taking the number line up here. What I've done is I've taken the number line and I've broken it up into different intervals that you can then test, find test points. So you're essentially going to find XY ordered pair points that you could plot, and that will allow you to do the graph on your own. And so I'm just referring, I mean, we've already answered the question here, but I'm just referring to what we would do if we weren't given, excuse me, excuse me, what you would do if you weren't given multiple choice graphs to choose from. Okay, so here you would just choose test points in the intervals, choose -3 here, choose a -1 here, choose 1, choose 5.5, and choose 7. And then what you're doing is you're plugging these into the function, getting a y coordinate that goes with it, and then you can graph out your graph. Okay. All right, so that's the process that we would use, but definitely this question actually we could answer simply by taking a look at the end behavior and nothing else.